Hello, welcome back to Geog 300, Geographical Data Analysis video series for West Virginia University. In the previous video, we looked in more detail at the t-test as a way of assessing the effect of a categorical variable or nominal variable upon a continuous variable. And that worked when there were two categories. What do you do, however, if there are three categories or more? That t-test cannot work anymore. That's when we switch over to this other technique called Anova, or Analysis of Variance. It's an acronym. Putting Anova in our same inferential statistics framework. So to really hammer that home, we have our question and setting it up as a null hypothesis. For a null hypothesis, the mean of every single group is the same across the board, all the same. It's important at this point to specify the alternative hypothesis because it can easily trip people up. This is not saying every single mean is different as the alternative hypothesis. For that null hypothesis to be false, we only need one to be different. It could be more than one. All we know is that there is at least one group mean that does not match others. We can think of this in a way from going all the way back to Sesame Street. One of these things is not like the other. One of these things just doesn't belong. Only one needs to not belong for us to acknowledge the alternative hypothesis and reject the null hypothesis that they are all the same. A lot of people will get tripped up and assume that, oh, well, that means they're all different. No, only one needs to be different. It so happens, and we'll see this in some of the tables that we get, the distribution in question is another letter that they just show up called the F distribution. And it so happens, the F distribution is typically skewed. Really, Excel is going to handle the math for us. We don't need to worry about that. The main thing here, because it is a skewed distribution, that question from the t-test of one sample or one tail versus two tail no longer applies. All we're doing, what it's doing under the hood is, in a sense, looking at under the null distribution or the null hypothesis, just by virtue of sampling error, we would expect there to be some difference. How much difference between the different group means do we expect before we decide, okay, it's not just sampling issues, there really is something going on here. Just picking a number out of 6.09. By itself, that number tells us pretty much nothing. It is based upon the sample size, it is based upon the number of groups. So really, we need to look at the likelihood of getting this value or greater under the null hypothesis. That ends up being the proportion that is shaded. That becomes our p-value. The extent to which the data supports that null hypothesis that they are all the same. If I get a very low p-value, and recall, we would be typically setting that threshold ahead of time. What I will be doing through at least most of the labs, especially in the earlier part of the course here with labs, I'll tell you what that threshold is. So it's sort of like, okay, I'm picking that threshold for you. In the broader sense, it would be best for you to choose, I want to use 0.1 or 0.05 or 0.01 or whatever value I want, based upon what are the consequences of getting wrong. And I compare then, I get my p-value, and I use that again to make a decision of, do I believe the null or the alternative hypothesis? There is then, Excel does not readily do it for us, but we can make it happen, and we'll actually be doing this in the lab. Just getting a significant result from Anova, strictly speaking, doesn't tell us what's different. All we know is that something's different, something doesn't match. But which one? Or which ones? It is common to then follow up with what's called a Tukey post hoc analysis, or Tukey post hoc set of tests. What you then do is you take each pair of groups and you do a t-test among each combination. So you're going to be doing a bunch of t-tests. It's not just one, it's a bunch. That's okay. To find out what's different from what else. Because if Anova went and said, yep, there's a difference, at least one of these t-tests should then come up as distinct to identify what's different. So to put an example through all of this, we might have, say, 100 different plots of land, and we want to know in an agricultural setting, does the soil type affect the productivity of growing corn? So I want to know, do I get more bushels of corn per acre from one kind of soil than another? We may have 4 or 5 different kinds of soil. Let's say there's 4. And we go and we say, is there a difference in corn production between the soil types in this area? We go, we find out, and it comes back and says, yes, there's a difference. Something is different. I don't know if it's soil type A, B, C, or D. So I then go to the Tukey post hoc analysis, and I say A versus B, they're the same. A versus C, different. A versus D, the same. B versus C, different. B versus D, the same. C versus D, different. And then I can conclude, okay, yeah, it's C. C is different. That's the most straightforward group. or the straightforward example with the Tukey post hoc here. It can be a bit more muddled, where I might find A against B is the same. A against C is different. A against D is the same. But B against C is the same. C against D is different. B against D is the same. So what I've found if I look at this by group, A, B, C, and I said D always matched, so D is there alongside A. B is between A and C. It's not notably different from either extreme, from either A and D, or different from C. But because C is different from A and D, it still shows up as significantly different within Anova, as well as in that Tukey post hoc. It just means we have a bit more complexity when we're giving the results of that Tukey post hoc, because it's not that C is different from everything. C is different from A and D. B, acting kind of as a bridge, is not different from anything else. So we can have more complexity in our Tukey post hoc analysis than a simple, this is the one that's different, everything else is the same. And that's something we'll be seeing, potentially, when we look at examples, again, with the labs and with the in-class demo. So as always, if there are questions, please feel free to ask, either by email or in the in-class Zoom sessions. For this batch of videos, we'll then continue going back to the packed part of the course, the writing and presentation part, looking at tables and results sections. So, have a good one.